So, do you want to know what science really is?
I
No,
would love to.
tell us.
Do you want me to tell
So
you?
can we go back over to the main? You want to go back over to my server on the main VC?
Yeah,
Or we,
sure.
okay, why don't we go there
Okay.
and then we can talk about it.
Okay.
All right, see you boys there.
See ya. Hello.
Hey, you're back.
Yes,
Back.
I'm back.
Hey,
Brought the man of the hour.
hi guys.
Hi. Okay. At least I think my stream is good this time. Can everyone hear me?
Yeah, I hear you.
Oh, okay. So does anybody want to ask me anything? This is the Ask Me Anything.
What is science, Mr. Slade?
Oh, it's a good question. What is science? That's actually the very first time I'm being asked a good question on this server. I think we should celebrate.
I think we should, but we should celebrate by answering the question.
Yeah. Anyway,
Wait a minute. Hang on.
No,
I
no,
ask
no,
a
no,
good-
no.
I ask a good
Omnivore,
question.
No, that is a question. Don't interrupt, Omnivore.
no,
Okay.
Omnivore. No, but Omnivore is right. He's one of the few that has been having a productive conversation with me these days. Yeah,
Don't
Omnivore.
support Omnivore.
Don't support Omnivore. Anyway, what is science? So everyone is wrong about science, specifically Feynman. Feynman is very wrong about science, but I think the one who made the first mistake was maybe
Feynman is wrong about science.
Feynman is wrong about science.
Okay. How do you
Let him cook, NASA. Let him cook.
Okay.
Anyway, I'll give you the answer. Then we can go back to Feynman and discuss Feynman. But so science is so the universe is under an obligation to be completely understandable. And
No, it's not.
well, my definition of science. So in my definition of science, the universe is under an absolute obligation to be mechanical, simple, intuitive, completely understandable by a little child. That's science. If you don't agree with that, then you're a religionist. You should go worship idols and ghosts and
Oh my God,
gods.
are you effing serious?
Yes.
NASA. I bet that's a better definition than what NASA would say, honestly. Let's be real.
Anyway, so the whole notion of this universe is weird and it's weirder than we could ever dreamed it could be, that's not scientific. That is the foundation of religion. And indeed, that is the foundation of a lot of nonsense. Like everybody uses quantum and a little bit of relativity for their cults. But
Can I explain what science is in my world?
yes.
The method of determining cause and effect relationships empirically. That's all science is for me.
Okay. But the question is the universe under an obligation to be understood, to be understandable? Is the universe under an obligation to always have a cause and effect?
Yes.
Okay. So you disagree with Feynman?
Well, I can agree that, causes, or there must be causes and there must be effects and they're tied together, but that doesn't mean that I disagree or that I agree that it has to make sense to you individually.
Wait. That's impossible. That's a contradiction.
No, it's not.
Yeah, I think it is. So,
Okay.
so you're saying that there is a cause and effect, and I'm going to look at a cause and an effect and not understand that I'm seeing a cause and effect. That's what you're telling me. But that's what you just said.
I mean, what about modern physics says that causes don't precede effects?
Causes don't precede effects? What do you mean?
Yeah,
Wha-
like that.
Mm-hmm. What do you mean?
Like what about big physics disagrees with the fact that causes don't precede effects?
I mean, I disagree with big physics because big physics, they always say, all the science communicators, they always say the universe is under no obligation for you to understand it. I disagree with that. I claim that the universe, the definition of science is the assumption that the universe is mechanical, simple, intuitive to a child. So I disagree with big science about what is science. And the day I understood the definition of science the way I understand it now, that's when I realized everything. That's when everything started falling into place. That's when
When was that?
You are very wrong on that.
I'm very wrong about what.
You're very
Most
wrong on
everything.
most everything, but that the universe is simple. It's not always simple, and nobody in science ever says that there's some obligation of anything. It just so happens that we see patterns in the universe, and those patterns in nature seem to be understandable. They may not be simple, but they do appear to be rational.
Yeah, seems to be is the best explanation for most stuff.
Yes,
Like,
unless we come across a miracle, which a miracle would literally defy all of natural study, would seem to have no pattern, no connection, which we have not yet had happen. Religious convictions notwithstanding. So far, science has never ever seen a miracle happen.
So, right, the definition. Let's break it down. So it's difficult to define, but I would say the definition of a miracle is the avoidance of the relationship of the cause and effect, is the violation of causality. I would say that's the definition. You are welcome to agree or disagree. Tell me what your definition is. But I would say the definition of a miracle of anti-science is the violation of causality. And so, look, if you agree that the universe is mechanical, that the universe is causal, if you agree that causality,
I don't.
okay, then you're a religionist. You believe in ghosts.
Incorrect.
You're wrong.
Look, it's down.
Just because you don't understand stuff doesn't mean it's fake.
No. What I'm saying, we can both not understand a phenomenon. I'm not talking about not understanding. I'm saying, what is the assumption of science? What's the definition of science? So I'm saying the definition of, by the way, you can hear me, right? So obviously, the definition of science is the assumption that the universe is simple, mechanical, intuitive to a child. That's my definition of science. It
Yes,
might
you're
be
very wrong.
Then your definition is incorrect.
well, it's my definition.
Yeah, I don't even understand it, so I'm close enough to think like a child.
What?
What about Feynman's famous quote? If you think you understand quantum mechanics, you don't understand quantum mechanics.
Yeah.
Yes, very, very non-intuitive.
Yeah. And the day I decided to disagree with Feynman, the day I decided that is a nonsensical, that is a religionist, that is a that whoever believes that statement believes in ghosts. Ghosts are downstream from that. All the cults. Look at how many cults have
Worship quantum mechanics.
Look at how many cults started from quantum mechanics or use quantum mechanics to.
No cult uses quantum mechanics.
They all do.
Sorry.
They all do.
Incorrect.
Everyone.
Incorrect. No, incorrect. Very few sciences are based in quantum mechanics. So you can go through biology all day and rarely talk about quantum mechanics
No,
unless you really get into biochemistry.
cults, religions,
No,
cults.
no. Religious cults could give a shit about quantum mechanics.
No.
You'll not see any place in I don't know, Lutheran doctrine about
Anyway,
quantum mechanics.
Okay, I'm not. That's I don't consider that a cult, but there's so much woo-woo based on quantum mechanics. Quantum mechanics has given
Only because you don't understand it seriously. There's very little woo in quantum mechanics. It's all based on equations. Does it make a lot of sense intuitively? No. Does it work? Yes, it works very well. Thank you.
Yeah. Just because Deepak Chopra unloads a whole lot of quantum bullshit, which he calls quantum, but really isn't, does not mean that quantum mechanics is in any way religious.
Anyway.
By the way, you are, in my mind, you are sitting right next to Deepak Chopra.
No, you are Deepak Chopra. I'm showing you. You are Deepak.
I am Deepak Chopra.
There you
Is
go.
there more
No,
who than woo?
I am Deepak Chopra.
I'm Deepak Chopra.
And I'm his good friend Jesus.
Sean, what do you think? Have you been listening?
Who's Sean?
Sean.
Anyway,
Okay, here he is, as long as he shouts bees.
what? Anyway, so you
Wait a minute,
are.
hold on. So you think you should be able to intuitively understand quantum mechanics?
I do. I happen.
do?
Yeah, I happen to complete.
You intuitively understand quantum mechanics. Oh,
Yeah.
please tell me about this. I would love to be able to understand quantum mechanics at an intuitive level. Go.
Ask me questions. Ask me anything.
Explain the double slit experiment.
That's trivial.
It's trivial. Explain to me why, when you observe it, the waveform collapses.
It doesn't. It's always a wave.
It does.
No, it doesn't.
It does.
No.
It collapses into, whenever you observe it, it collapses into two bars like they're particles. If you don't observe it, it goes back into the wave. Why?
No, because you block one path. Anyway, it still behaves like.
Incorrect. No. We don't block a path. We just observe it.
How do you observe? You don't interfere with one of the paths?
No, we don't interfere. We just notice which one it goes through.
What do you mean you notice? How do you notice?
Or you measure it.
How do you notice? Tell me about your device. How do you notice? How do you notice? Tell me about the actual device that is used to notice.
Well, it's not blocking anything. It's just It's just counting which one it goes through.
So I would claim that you're interfering. You're blocking. Look, the way it
No,
works.
not blocking. No blocking involved.
Then tell me, fine. Then tell me about your equipment. Tell me
Well,
about.
the simple one to understand is when you polarize light.
Well, we're talking about the double slit experiment.
You can do that. You can do the quantum eraser in your house if you want to.
Wait, I'm not talking about. I'm talking about the simple double slit experiment. Let's talk about the. You want to talk about the photon one or the electron one?
Either one.
Let's go with the photon one. All right. What's the question?
I just want to say, because I'm really proud of this, I've managed to do the double slit experiment using a laser and a human hair.
Yes. I've seen that done. Yeah, 'cause,
I did it with the sunlight in full color.
Yeah, but
that was your.
What-
That one's a little bit less, because the wavelengths are different, right? But
Yeah,
it still
but-
gives you the same effect.
the double.
Hey, don't diss my accomplishment by saying that you have a better accomplishment.
I know. I understand. It's possible to be done.
Anyway, back to your questions about quantum mechanics. Ask me anything.
Explain quantum mechanics in 25 words or less. Go.
What's the question? Ask me a question. What don't you
The
understand?
question is, explain to me how quantum mechanics work in 25 words or less.
Do you want to talk about the double slit experiment or no?
Yeah, how's it work when I observe going through one? When I'm not looking, it gets the wave, but if you observe what slide it goes through, you can.
What do you mean observe it? Tell me about the mechanism that you use to observe it.
You can polarize the light and then.
What do you
come
mean?
back.
What do you mean?
Guys,
Polarize the light? What do you mean?
check out the general chat from my full color sunlight double slit experiment.
That's cool.
Oh,
Now you get a little
I'd
bit
use that
overlap
as
with
a
the frequency
screensaver.
there.
That's good enough for a screensaver, that one.
I like the first one's the overlay, right? And then you break it into various wavelengths.
Yeah, the first one is just the image from the CD sensor on my camera, my DSLR. Because I took the lens off and I put the double slit on the front of my DSLR.
But that's not a single photon.
Well, so I stretched it. Let me get you a section of the actual single photo.
Single
Photo,
photon.
not-
Single
No,
photon.
that's not a single photon version there that Jesse has. Jesse hasn't done it with single photons.
So if you don't do it with a single, the whole point of the double slit was to prove that a single photon interferes with itself. Otherwise, like if you just assume it's waves, then it's just waves. Then there's no question. So
It's not waves. If you want to go particles, then you have to shoot single electrons at. That's a little bit more difficult.
okay, so how are you detecting without interfering? You're polarizing it. You're putting.
Well, if you want to start talk single particles, it's a little more complicated.
I think the more interesting question that would probably put what you're trying to say in better relief would be to explain how it is in quantum mechanics that the solution to the ultraviolet catastrophe and the double slit and the solution to the double slit experiment can work together in an easily explainable way.
What's the question? Why is there
Your
even a
mother.
question? Wait, so which experiment do you want to discuss? Like
Okay, so first, do you know what the ultraviolet catastrophe is?
pretty much, sure.
Okay, so you know what that is. Good. All right, and you know what the double slit experiment is, correct?
Pretty
Wait,
much.
I don't know what the ultraviolet catastrophe is. Explain.
Okay, so the ultraviolet catastrophe deals with black body radiation. If you have a radiating black body source, and as you heat it up, you get a light curve. Okay. If you use the assumption that light is a wave and therefore infinitely divisible, you get a different predicted curve than what you actually get. The whole reason we call quantum mechanics quantum is because the solution to the ultraviolet catastrophe was to quantize light and say that it can only exist at discrete energy levels, ergo particles. Quantum mechanics originates from trying to find solutions to the ultraviolet catastrophe.
And the reason it was called the ultraviolet catastrophe is that as you increase to shorten the wavelength, increase the frequency of the light, it carries more energy. And even though there is less of it, the predictions from the naive wave model were essentially, if you integrated up to infinite wavelength, you ended up with infinite energy instead of tailing off in a correct manner to what was observed experimentally. That was the thing. There was a consequence. The Rayleigh-Jeans law was one of the ones that was trying to answer it, and that one had the catastrophe at the high energies.
Yeah, and so the basic problem with trying to have an easily understandable explanation for both the double slit experiment and the ultraviolet catastrophe is because the double slit experiment basically makes a statement that light operates as a wave. The ultraviolet catastrophe says it operates as a particle. These, under normal macroscale circumstances, are two mutually incompatible categories for something to exist within. That is what my opinion as to why quantum mechanics can, well, that and indeterminacy, so difficult to understand.
Anyway, for me, I don't even see the question. But let's go step by step. So so for me, everything is a wave. So let's see how.
You're incorrect. You're incorrect because of the photoelectric effect.
Right. So let's go.
If you say everything is a wave, then you are in contradiction to the ultraviolet catastrophe.
and the electrons. Electrons are particles, and we can fire them at the double slit and get a wave function. How's that work?
Because it's a wave. But let's go step
No,
by
it's
step.
not. No, they're particles.
You just said it's a
They're
wave.
particles.
Fine. Look, you just said it's a
They're
wave.
both. They're photons. See, the problem is photons are both, and
Anyway, let me complete a sentence, and then you can react.
Wait, hold on a second. When you say everything is a wave, you have been proven to be incorrect by science. Okay, I'll shut up here in a second, Sean.
Yeah, be quiet because I want to hear him explain
Okay,
how
fine.
everything being a wave, specifically light being a wave, works with the ultraviolet catastrophe. Because remember, he said he knows the ultraviolet catastrophe, so he would have already thought of how a wave function, a wave can operate and produce the real measured light curve that we see from black body objects.
Right. So certainly today that we have Bohr's model. We can use Bohr's model to understand it. So basically,
Bohr's model?
Yeah.
Are you serious?
Yeah.
Let him cook, NASA.
Please, yeah.
NASA shut the fuck up.
Yeah, let him continue.
Yeah.
Let him continue.
Yeah. Anyway, so we're gonna use Bohr's model. I think it's the simplest, the best. Anyway, so with the ultraviolet catastrophe, so you're heating up an element, like let's say hydrogen. So you're heating up hydrogen. You're causing the electron to go up an orbit, and then it's unstable. It drops in orbit, and it causes a vibration. Now this vibration, that's just an electromagnetic wave. It's a tiny amount. It's exactly the amount of the energy of the dropping of the electron from orbit, let's say 2 to 1 to the lowest. And that vibration is what we call a photon. It's a wave, but it's a special type of wave. We call it a wave packet. It's a wave with a direction, with a momentum, with a location, delta x, but it's a wave. It's a wave packet. So, but it is, right, because of basically de Broglie. So from de Broglie we have the lambda, the wavelength of the electron. So Bohr said, yeah, go ahead.
May I ask a question in
Sure,
regards to what you just said about
Well, hold on,
Bohr's
let me just
model
rephrase
and
something real quick, which is that Mr. Slave legitimately thinks that electrons do orbit nucleuses. You can go on.
Okay, so are you okay if I ask a question in regards to what you just said?
Sure.
All right. So one of the fundamental principles of waves is that they are essentially infinitely divisible, and there is no quantization. If you go from one wavelength, it is perfectly smooth without break to another given wavelength. How do you get to the quantization that is required, as far as we know thus far, to solve the ultraviolet catastrophe?
That was exactly my next sentence. So de Broglie gave us from the momentum. Anyway, from de Broglie we have the wavelength of the electron, and Bohr said that the electron can only orbit in an integral multiple of the wavelength. So n equals 1 is the original wavelength, and then you can go to n equals 2 and so on. But that means that when the electron creates a wave, it can only create a wave that is quantized from orbit 2 to orbit 1. There is no other way to create a photon. There simply is no other way in nature that I'm aware of to create a smaller bit of energy, a smaller wave, and that is what causes the quantization. So maybe the photon, maybe we can create half a photon if we had, I don't know, a different universe. But in this universe where we have electrons creating photons as they fall from orbit 2 to orbit 1 and they smack against the lowest energy level, that smacking, that I was just imagining, like take a rubber band, put it around your wrist, open it up, and then let it go all at once. As it snaps onto your wrist all at once, it creates a shock wave. That's the photon. Anyway, so it's quantized. It's not quantized as a particle. It's a quantized wave. So
Okay.
but it's a wave.
So can plasmas generate light?
What's a plasma?
Plasmas are generally, okay, let's see if I can properly define this. A plasma is a state of matter where the electrons are decoupled from the protons.
So
Is that accurate? Can anybody else make that more clear than what I just said?
so
Sounds about right.
it's
Yeah.
it
Okay.
sounds it sounds like a free electron. So a free electron, as far as I know, does I don't know. I don't know anything about the mechanics of free electrons. I don't know. But what I do know about the UV catastrophe, that's the explanation. It's very simple. It's like you can theoretically divide a wave as much as you want, but nature doesn't produce these any size you want waves. It produces, the only way to produce a photon that I know of is by an electron dropping orbits, and then you get these these very specific waves or wave packets.
Sorry, but you're wrong there.
Mm-hmm. About what?
You can produce energy at different energy levels other than the quantized states of individual atoms.
Okay, how?
Ever heard of particle accelerators? That's how.
So what you're saying, that it's possible to create half a photon?
No, I'm saying that you can produce a photon at almost any any arbitrary wavelength that you want, even the ones, including the ones that are not a nice integer multiple of what you're calling the energy levels.
Yeah, there are other ways aside from jumping energy levels in an atom for generating this. The one I was getting to, and I didn't even think about the particle accelerators, but yeah, that would do it. I was more thinking about the fact that the electron in plasmas is decoupled. So a prediction of what Mr. Slave here is saying is that the light generated from a plasma would not follow the same predictions that the quantized black body predictions give. I'd like to see him prove that.
Wait, but look, we're dealing with a specific experiment. The UV catastrophe is a very specific experiment, and the reason why they were getting the graph that they were getting is the way I'm explaining it, and I don't see the issue. Just thinking.
Well, you're making a prediction that if we could generate light without it being generated from an atom of some kind, then you would be able to essentially have infinitely divisible scales between wavelengths. There would be no quantization in it, because you're saying that the quantization that was found is a product of electrons jumping energy levels. We have now given you two different methods that light can be generated without you requiring electrons jumping energy levels in an atom. So can you now show us, using this new knowledge that you may have, that you don't need atoms to produce light, that under certain circumstances, the equation for quantized black body radiation, i.e. the answer to the ultraviolet catastrophe, does not hold under these circumstances?
I lost you completely. Can you ask a smaller, simpler question? Let's talk about
Did I lose anybody else?
Let's talk about just the
I can
UV.
follow.
Let's just talk about
Okay.
let's just talk about the
Can
UV.
you?
Let's just talk about the UV catastrophe. Let's finish that. So the UV.
We're still talking about that.
Okay. So let's-
Totoro, would you be able to explain in more simpler terms what I just said? I'm eating dinner while we do this, and maybe you'll have better luck.
Why are you so
Can you
mean? Why be so mean? Like,
you
like-
wanted your theories tested. We're testing them. Don't cry foul.
no, just
And
don't.
I'm not being mean. This is just how I am when I'm talking about technical subjects. So I apologize if I seem mean, but this is not me being mean.
Yeah, no, you're being super nice, actually.
No,
Yeah,
no.
so the cool part about the ultraviolet catastrophe is every time you make a piece of toast, you are using basically quantum theory there.
Anyway, going back to the discussion. So first, please, everybody, don't be mean. There's no reason to be mean.
Okay, get
Just
over it.
be nice. Anyway, so look, let's just talk. Let's forget about plasma and particle accelerators for now. I don't want to I don't want to talk about too many things. Just talk about UV catastrophe experiment. Explain that with a wave, and then we'll go to the double slit experiment. Explain that with a wave, and show there's no contradiction. Both are waves. Everything's fine. So the UV catastrophe. So waves are not infinitely divisible when you heat up, let's say, hydrogen or any chemical, because the electrons, you need to cause the electrons to fall specific orbits, so you get you get waves, but you get them in packets, so you get quantized waves, and these waves have a location, a direction, a momentum. But they're not particles. There's nothing moving through space. There's something waving through space, but there's nothing moving. The photon is moving, but there's no particles of photon moving. Rather, it's an electromagnetic disturbance that is propagating, just like any other wave. But it's a
And how do you explain the
Hold on,
photo?
let him
I thought he was
continue.
done. I thought he's not done.
He said he wants to talk about the double slit experiment. I was going to let him ramble for a little while and
Wait.
get into the double slit experiment,
Wait.
and then I was going to bring him back and
Felkami.
ask him about the
Felkami.
Photoelectric effect.
Oh,
Felkami.
well,
Don't say
more
ramble.
about
Felkami. Don't say ramble. Come on. Don't be mean. Please stop it. Just be nice. There's no reason to be so mean.
okay. I admit I was being mean
It's
when I
fine.
said rambling, but it's a little bit aggravating to hear you say the same thing 3 times and then tell
I'm
people
sorry.
to
Then
just listen.
I didn't tell anyone to just listen. I always stop when I'm stopped. And I'm sorry if I'm repeating. I'm sorry if I'm being mean. Okay, let's de-escalate. Everything is fine. What do you want me to do now? Does anyone want me to do to talk, to not talk, explain, not explain, repeat, not
Well,
repeat?
What I'm really interested in regards to your theory of everything, and I'm not saying theory of everything to be mean. That's how I've heard people describe what you're saying.
Yeah,
And so that's a
fine.
term that is officially out there.
Yes, it's fine.
Okay. I'm still intrigued by the fact that you said that the only reason that light is quantized for the ultraviolet catastrophe is because it is generated by jumping energy levels in an atom.
Mm-hmm.
But the implication of that is if you can generate light without it being generated from jumping energy levels in an atom, it should not be quantized. The implication of that
then how
is that it should then diverge.
Stop. Hold on.
From okay.
No. Yeah, hold on. So when you say so give me an example. How would you create a vibration in the ultramagnetic field?
Well, we've given you 2 examples.
Yeah. Take one of them and let's go through it. So pick one and let's discuss it.
Okay. So the one that has an official formal name is synchrotron radiation, which is what Totoro was talking about previously.
Yep.
with the okay. Now the one that is much more
No,
manageable for you to produce, so that you can actually test your theories,
no.
would be plasma.
Okay, pick one and let's discuss the details. So plasma or synchrotron, what's your preference?
Let's go synchrotron because it is more well understood and pretty thoroughly measured, and that'll also get you and Tutorial talking and
Okay.
me eating.
Okay, so can somebody explain to me synchrotron, whatever?
Synchrotron radiation.
Synchrotron radiation. What is that?
That's what happens. It's a kind of electromagnetic emission that happens when a charged particle is accelerated. And it is proportional to the, well, it's essentially proportional to the kinetic energy of the particle.
Isn't that the Lorentz force? Or
Well, you accelerate a charged particle by using a Lorentz force, but
Lorentz force is velocity, and that's acceleration. Or...
Lorentz force is the force that a charged particle experiences when it is inside of an electric and or magnetic field.
Yeah.
So the question is, okay, so we all agree electromagnetic radiation is a wave, yes or no? Because that's the crux of the debate, right? That's what we're discussing.
No.
Is the question, is the electron a wave or no?
No. I said electron. I meant the EM wave. We all agree that EM wave is a wave, right? The photon is a wave.
Electromagnetism can be viewed as both particles and waves.
Okay, when you say
depending upon certain circumstances. If you want to be super duper technical, it is a disturbance in a particular underlying structure called the electromagnetic field. But that gets into some heavy QM.
Okay, so I was asked to explain the UV catastrophe and the double slit experiment, and to show that there's no contradiction. So I said they're all waves, and that explains everything. And then I was challenged. So could somebody ask me questions? Because I think I answered all the questions. I don't think there was a question. So please ask me.
Well, the criticism we have is your explanation for the ultraviolet catastrophe does not bear fruit. Because the ultraviolet catastrophe has not proven to be wrong even at very high energy levels. And those energy levels being where the electron or some particle is generating light without being part of an atom.
No.
The synchrotron.
No.
So
no.
Let me see if I can better explain synchrotron radiation to you, because I'm not sure that Tatora's explanation was sufficient. So synchrotron radiation is a real thing that particle colliders have to deal with. And yes, it is the tendency for an electron that is accelerated to high velocities to produce radiation of varying types. But the reason we call it synchrotron radiation is because it has been most documented early on in a type of particle collider called a synchrotron, which is basically the particle colliders you see that are giant rings. Because when you use a magnet to change the direction of the electron, that is essentially an acceleration that produces X-rays.
But I'm lost. I'm sorry, but
I don't know. I'm sorry, I don't know how to explain it more simply. But if you have an electron traveling at very high velocity and you change its direction, it produces X-rays.
No. I'm lost as to what's the question. I was asked a question about, like, I was asked, can I explain quantum mechanics? I said, hold on.
Is English your second language?
Hold on. So I was asked to explain quantum mechanics. I said I understand it thoroughly. Ask me anything. So let's maybe start over. So does anyone have any questions about quantum mechanics? Does anyone not understand quantum mechanics?
have you changed your opinion on understanding quantum mechanics thoroughly now that you realize that your assumptions about the ultraviolet catastrophe are wrong?
Okay, I'll ask again because I don't know what you're talking about. So does anyone have any questions about quantum mechanics? Yes or no? Do you have a question about quantum mechanics?
Whistled right past it.
What?
So let's
I haven't got any questions because I don't understand it in the first place.
No,
so-
does
let's
anyone?
go back to the double slit experiment. Single
Sure.
photon version, single emission, and yet it produces an interference pattern, but it
Mhm.
only impacts the target at one spot. Explain.
Well, it's a wave packet. It's a wave. It's a tiny wave that apparently goes through two slits, but after it goes through the two slits and interferes with itself, it's still one packet.
How? How did it go through two slits?
As a wave. It's a good look. It's a good question. So it's going through two slits.
But it only ever impacts in one spot.
Yeah,
And
I
the
mean,
pattern that they make after you fire enough of them produce an interference pattern, but they only ever, when you actually run the thing, impact at individual points.
right.
Explain.
So look, it seemed. Look, all I can do is look at this experiment and tell you what I can imagine is happening mechanically. So what's happening is there is a wave packet that is a photon. It has a certain size. It goes through the two slits. But as it's going through the two slits, it's still one thing. And
So your wave packet that is supposed to have a position now has two positions. It goes through both slits at the same time.
right, but it's big enough that as it's going through both slits it's going through
But
both
when it-
slits. Yeah.
But when it impacts at the other side, it is much smaller than the separation between the two slits. So how did it span itself out just to go through both slits, and then it recompactified itself just to hit the detector at one spot?
That's
It needs to
good.
be doing a lot of knowing ahead of time what it's going to have to be doing.
Yeah, that's a good question.
It's not the particle itself that, the individual particle does not make an interference pattern. It's their collective impacts over time, this kind of stuff. This is what you would see at the detector over time build up. But the individual impacts are always only one spot.
I'll tell you the truth. I've never seen. Have you ever seen a double slit experiment conducted?
Yes.
With a single
You probably didn't. Yeah, well, you probably didn't search enough on your YouTube trips. But Veritasium has done a double slit experiment with individual single photons.
No, he didn't.
Oh, yes, he did.
I know every single YouTube double slit experiment.
Every single one.
Yeah, show me Veritasium's.
Do you click play in your mind and you can see them all?
I know them all. I've been through them multiple times. I have videos about going through every single YouTube video about every single double slit experiment multiple times.
Here you go.
You have it?
With timestamp.
Fine, let's see it. Is it the one with the box from 11 years ago?
Whatever.
Is it?
So what?
That's not a single photon.
That is a single photon. You've got a detector there counting photons, and per second it only shows something like 3 to 7 photons being received at the receiver.
Let me see. Okay, maybe I'm wrong.
He even says that.
Let me see. You have it? You put it?
Frequency counter, which actually counts the number of photons received per second at the detector. The detector is a photomultiplier tube, which is capable of detecting single photons. It's like a very sensitive eye, like the frog's eye. Now, right now, there's no light passing through to the detector, but there is still a bit of a background through this room, which, as a function of position, random. There doesn't seem to be any pattern in the arrangement of those photons as they hit the detector. So maybe it's true. A single photon can't interfere with itself because it's just a localized point. Add up the you can photons through, but what pattern is happening? How can I interpret that in any sense?
Where is it impacting? Where's the
On a photomultiplier tube.
That device. There other
Does he
bright
show
spot,
it?
Because now the light from one of the each slit has to travel the
I don't
same distance to reach
know if
that
he has an
point,
actual
and hence
direct
both
shot of the
waves are
entire
in
pieces,
phase. That means
all the
press
pieces
and
individually.
so they add
It's like
Yeah.
213 roughly.
Yeah, I mean,
Yeah, about 213, 220.
213.
What, are you trying to now accuse him that he's not actually performing the experiment correctly?
That is
I'm not accusing. I'm completely open-minded. I'm trying to. I'm honest. I'm trying to understand. I'm here to be disproven. I'm not here to be proven.
faint source and to see
Well,
where the light was going.
So where is?
Feel free to.
So okay, let me understand the apparatus. So
I had to shroud my head in that black cloth. But I finally have the
There's a
apparatus ready. You can see up
very
here, I
weak
have a
light source on
frequency
one
meter, which
end,
actually counts the
an
number
enclosed
of
tube
photons received
with a
per
double
second.
slit,
That single
and
photon
on the other end is
transmitted
a photomultiplier tube.
what's a photon multiplier tube?
Photomultiplier tube.
Right. So
I
It's another way you could use as a CCD. It's another type of sensor which lets you detect individual photon interactions.
mhm.
So I haven't read it, but I just posted a link to a science journal called "Video Recording True Single Photon Double Slit Interference."
So your question is, how can it be that the slit is big, but the detection is tiny? How do we know that the entire energy of the photon is in localized to one spot? What do we know about this detection?
Well, we know it can detect individual photons. That's what we know
How do we know?
because we've tested it.
How did you test it? What is it?
Don't really know how the CCDs work. Presumably, they're able to do it.
CCD, if I'm not mistaken, is just a photoelectric effect from Einstein. So a photon
Don't
just,
remember exactly.
I think a photon just releases an electron, and the electron causes current. So that's the detection.
Well, yes, it is a electronic device. Yes.
No, I'm saying the way to convert a photon into a detection is through the photoelectric effect, I think. So
Yeah. So.
No, I'm just trying to, because he's not explaining the mechanism, so I'm just trying to understand it. Because you're saying, so okay, I don't. The truth is, I just don't have enough information. I mean, this is something I've been
Okay.
looking for.
So you're trying to discredit the experiment instead of trying to provide an experimental explanation for it.
No, I'm not.
Yes. That's what you're doing right now.
Well,
You're trying to look for some sort of a loophole that allows you to say that no, the photon didn't really go through both slits at the same time, or there's some other problem with the experiment.
No. So I'll tell you my theory. So look, I come from a place where I say science assumes the universe is mechanical, intuitive, understandable to a child. That's my definition of science. That's
right.
my definition. And this is what this discussion is about. So based on this assumption, I'm trying to explain the evidence that you're presenting. So the photon to me is a wave. That happens to be true because of the ether. The photon must be a wave. Everything must be a wave. So let's assume it's a wave.
Huh?
Anyway.
I think that. What was that? Was the like? Oh my god, that was the biggest jump in logic I've ever heard in my life.
Yeah, can I ask why science should be explainable to a child? You
That's
don't
just
expect them to understand law.
That's just my definition of science. Science.
Hey,
Mac-
don't bring me into this.
Mac and cheese, you get on the mic right now, bro. Get on the mic.
Anyway,
Well, if it's explainable by a child, can't you explain it so you are talking to a child?
well, that's just the
I
definition.
just posted the video from the article that I posted showing a single photon by single photon double slit experiment.
But how do you know that's a single photon?
Read the article and tell me.
No. So I mean, you tell me. I mean, you're presenting the evidence, so you need to read the article and tell me.
As I said, okay, whatever, man. So you're saying that this article is
No.
lying?
No. Well, no. Stop it. No.
The title. Hold on. The title of the article is literally "Video Recording True Single Photon Double Slit Experiment."
Okay,
And
but
you're
I'm
telling
asking.
me that it's not single photon.
No, I didn't tell. I asked, how do we know? How can we know? I'm being skeptic. I'm being skeptical. I'm being scientific. How can we know what we're being told? How can we validate, verify, whatever? Because in my mind, what you could have theoretically is you could have a photon going through both slits. Apparently, it's going through both slits. A single photon, if we're able to. The first question is, are we really dealing with a single photon going through?
So my question for you is this then. If every single quote unquote photon emitted is its own individual wave, then why in the video that I posted does it exhibit as individual dots appearing on the detector one at a time?
How do we know it's one photon and not two?
How is it that you can have a wave be produced that appears on the detector as a single dot and not a wave on the detector?
Maybe it's tiny. It's a tiny wave.
Sure, if you want to go that way, call it a tiny wave. Then you have to
It's
explain
actually-
why that tiny wave went through two separated slits at the same time.
It's a ultra mega gamma ray that basically acts like a particle and a wave at the same time or something.
No,
there you go.
I'm calling it, dude. You said that you understood
No.
quantum mechanics, and I'm saying right here, you are an example of somebody who thinks they understand quantum mechanics, does not understand quantum mechanics.
right. That
And
is
certainly would have known what a photomultiplier tube was.
So let's say a photon. So you're saying a photon is not big enough to go through both slits? It's too small.
The slits are separated further apart than the individual detector pixels are. So, what gives?
What if?
And each
Mhm.
each detection only trips one pixel.
Okay. So what if?
Whatever hit it must be smaller than that.
Okay. What if it's coming in as a wave that is spread, but as it's interacting with an electron, it's like being sucked into that electron, right? Because ultimately it's trying to pick up an electron from its atom. It's trying to
So
dislodge.
your packets of electromagnetic energy, wave energy now, are smeared out, but they collapse to a single point once they interact. Did you just reinvent quantum mechanics? Like you've literally just described the wave function and the collapse of the wave function.
But there's no particle. I did all that with no particle.
Sure, Call
everything.
it whatever. Call it a shmoo if you want.
No, it's if we just did that, if everything fits the data and we were able to do that without a particle moving through space.
You just postulated the hypothesis that somehow the photon, which you call packet of wave ether or whatever, went through both slits, but on interaction with the detector collapsed to a single point, to a single electron, whatever. You literally just reinvented quantum mechanics and the fundamental principles of the wave function and the collapse of the wave function. So good job. Welcome to quantum mechanics.
No, I did it mechanically. Everything in my mind, what you just
Totally
said.
mechanically.
Right. So ask me anything.
That is literally quantum mechanics. That is how it works.
Then ask me anything. What
is the mechanism by which this wave produces a single dot on there, but still interacts with all of the other single dots to produce a interference pattern?
It doesn't interact with the other dots. It goes through.
Then why is there an interference pattern that is created by multiple little dots?
Well, when a photon, that's easy. When a photon goes through the slit, it's smeared out. It behaves like two different waves that are coming out of the two slits. They interfere with each other, but it's still maintaining its integrity. So it's still one unit, even though it was just split up by the slit or by the barrier between the.
But didn't you define your photon, your little wave packet, as having a definite location?
No, it's a
Yes,
wave.
you did. You said it has a dx. It has a
a dx.
A discrete dot is a definite location.
No, it's a dx, like Heisenberg's uncertainty. It's a wave.
Okay, so how big is that dx?
Well, big enough to go through both.
Could it be a meter?
I don't know, but it's big enough to go through both slits at the same time.
So how do you define that dx?
I want to get a question or a statement in.
Go ahead.
When I'm looking at these images of the double slit, to me the light going through and then coming out as these patterns, it's like a refractive pattern, like how our rainbows are formed. Is there any similarities?
It's an interference pattern. So it's like two waves that are overlapping each other. And
So is there any refraction involved, or?
No, this is more diffraction. This is a different type of effect.
Right, okay.
Refraction is the change of direction of light. Diffraction is where light, or any wave effect, in fact, that goes through a hole that is smaller or comparable to the size of the wavelength, will, on the other side of the hole, spread out in sort of a semicircle. Yeah, that's what happens.
So depending with compared with light and a wave, it's because it's a wave it does that. Yeah, I understand what a wave is.
Yes, light behaves as waves for the purposes of diffraction and interference. Yes.
Right. Okay.
But on detection, it always collapses down to a single point. Each photon only presents itself as a single point. The trick for the double slit experiment is that even if you fire individual photons, which obviously at the detector only trigger one pixel, only hit one very definite point, yet they still produce, even if you fire them in sequence, they still produce this interference pattern. So it's behaving as if the photon went through both slits and interfered with itself. That's the paradox, so to speak, of the double slit experiment, or the sort of mind-bending part of it, which our intrepid quantum physicist here has yet to explain with this theory of ether, which apparently has a definite position for a photon, yet it can also go through both slits at the same time.
Is that where the phrase that the particle and a wave come into it, or is that something different?
Yes, this is a direct demonstration of wave-particle duality.
Right. Okay, back to the conversation.
All right, so let's say how do we know that it's a single photon that's coming out from the emitter?
You're looping back. It's not a question of a single photon coming out of the emitter. It's a single photon being received by the receiver.
How do we know? Maybe it's multiple.
Well, you can remove the slit if you want, and then you can just count it directly on the photomultiplier tube or on the CCD, and they'll still come out as single photons. So, and we don't care about the photons that do not go through the slits. We care about only those that go through.
So it could be that each dot is really multiple photons.
No.
Why not?
Why would they recombine always in the same spot?
So it's
How would you
always
have
Photonic-
two?
Yeah,
So it's-
photonic reattraction.
so it's
By what
always
mechanisms would they always recombine to the same spot, even if you have multiple of them?
so it's always the experiment, the way it's conducted. We fire a single electron, and because I see multiple dots appearing in every timestamp, it's not a single.
That's because it's a time. That's because this is a time lapse.
So the question is, what actually is it? One by one? Is it like each
Yes.
time? Okay, so each
Yes,
time.
it is one by one. The experimental apparatus typically is about a meter long. So by the speed of light, you know that the photon takes like a fraction of a nanosecond to get there. So even if you detect like 10 detections per second, that means that for the vast majority of that time, there was no photons traveling through that slit, and just occasionally one of them blips through. It's
Got
just it blips through so fast that if you count them up per second, they get to multiple detections per second. It's still a very low number, and yes, they still fly by individually on their own.
Okay, so a single photon goes through. Now, for each photon that goes through, we always get a detection.
Pretty much, yes.
Sometimes we don't.
Well, the detector is not, it isn't a completely enclosed hemisphere around the other side of the apparatus.
Mm-hmm.
Occasionally, they might fall out, away from the detector. But we don't
Mhm.
care about those. We care about the ones that do hit the detector.
So
which is
what's
still, even if you accounted for all the ones that don't hit the detector, still nowhere near enough. It's not like there's this mega stream of particles and just occasionally one of them hits the detector. No. Most of the time there's nothing going on. Sometimes a particle goes through, and maybe on occasion it doesn't hit the detector. Most of them will, though.
Okay, so we fire a photon. What's the size of the thickness between the two slits? Do you know? Is it a hair?
Typically they'll be a few millimeters apart at least.
A few millimeters? No.
Yes, but they can be even further apart. As far apart as you need them, really, for the size of your experiment. They could be meters apart if you wanted to make a really big one.
Wait, how?
But typically, they'll be a few millimeters apart.
What do you mean a meter? A meter apart? How?
If you wanted to make a very big version of the experiment, you could put them meters apart, but
How?
then you would have to have a giant CCD on the other side. So typically they'll be a few millimeters apart.
What would you fire?
Photons.
But how do you
Still
fire?
same thing.
How do you fire a single photon? Like, would it be a radio wave photon?
No, it'll be visible light.
Visible light. Visible light
Yes.
is tiny. The wavelength is
Yeah, I know, right? Funny, huh?
what?
It's only a few hundred nanometers.
It's red light. What is it? I don't remember. 665 nano or something, or
It's
6.5.
about 700 nanometers.
Okay, so so you fire a single red light photon, and you're saying you can have your slits as far apart as you want, even with red
Pretty much.
light. Even with red light.
Yes, pretty much. You would still get an interference pattern. You just have to have a ginormous detector and wait for a very long time to accumulate enough of them to make a nice pattern. So typically the detector is much smaller. The slits will be a couple of millimeters apart, and you'll have a few dozen square millimeter CCD on the other side.
Have you ever seen this? Has anyone ever done this?
Veritasium videos literally shows you that device and how it's detecting.
Meters.
He uses a photomultiplier tube. And by the way, the video that Pelkami posted for you, that is from another experiment. So yes, people have seen this.
So there's a Veritasium video where he fires a single photon. It goes through two slits that are meters apart.
No, not meters apart. Typically, they'll be millimeters apart. But the principle holds. Nevertheless, it's already tens of thousands times larger than the wavelength of the photon, so that's not going to save you.
You were mentioning a second ago about the color of the light. Does that make a difference compared to white light and
No,
you
not
said
really.
red?
Well, white light is just a combination of different wavelengths. It's easiest if
Right.
you have just monochromatic single color, single wavelength light.
Okay.
Typically, you want a sufficiently high frequency or short wavelength such that you're not going to get into some other scattering problems. With radio waves, you could actually use much larger gaps. Radio waves have wavelengths much bigger. So you could end up with, the slits wouldn't have to be very small. In fact, diffraction of radio waves is one of the ways you can actually receive a radio wave, like standing behind a building, even though the transmitter's on the other side of the building. But
Okay.
then it gets really messy.
Has he explained yet why the waveform collapses if you're observing it or not?
No. So far, he's still in the denial phase.
No, there's no denial. I mean, I never had this data to contend with, and usually it's impossible to talk to people about this. So this is the first time I'm having a conversation about this topic. So,
Well, I mean, I applaud you for rediscovering quantum mechanics from this data. So that's a good thing.
yeah, I mean,
And wave function collapse. So that's another good thing.
Yeah, wave function collapse when you observe it. Interesting.
Yeah, I mean, you're literally, dude, you're almost right there. You just refuse to take the last step. You already said that what if the photon goes through both slits, but when it interacts with the detector, it collapses into a single point. That is quantum mechanics.
I mean, if
We
that's
call it different names.
But the question is, what's the mechanism by which suddenly something so big collapses into something so tiny?
Yeah, and that is where you get to
The
the wave function.
interpretations, right?
Yeah, I mean the interpretation is if you do whatever you want, but that's sort of between you and your God. But the mathematics of the wave function do give you this.
The
Or the wave
mathematics,
function.
the mathematics of the wave function gives you what?
It gives you a probability distribution that you're going to find the photon at a specific point. You just run the math, crank the handle on it, and out comes a prediction. You compare the experiment, and it is extremely highly precise. And I'm just laughing at the sea lion meme there.
I'm stealing it. I like it too much. I'm stealing it. That's good.
I didn't see anything. Anyway,
What I missed, I was too busy reading.
anyway,
The train with the bus. That's a good one. I like it.
Oh, okay.
anyway, so you're saying that you're firing a single electron,
Single photon, yeah.
a single photon. It goes through two slits. That you don't care what the distance between the slits is. That
Well, that has to be small, right?
The distance it just depends upon the size of your detector. You can make the separation between the two slits as big as you want. It's just then you have to have a ginormous detector on the other side. And making a, I don't know when the last time was that you priced out the CCD, but CCDs and silicon, by the meter is a little bit expensive to come by.
okay, I'm a little bit confused about this experiment that you're describing. So
I can believe that.
don't be mean. Come on, stop. Anyway,
I'm not. I'm following along as we're talking and asking the right questions.
I wasn't referring to you. I was referring to Totoro. Anyway, so I don't understand the experiment where you're saying you can separate the slits as much as you want by a couple of meters. I can't imagine such an experiment. So you're saying
then just think of the one that is actually presented to you where the slits are separated by a few millimeters.
No, I mean I want to have as much data as I can. I mean, if you can separate it by meters, that's how I
Yeah.
can't imagine that.
And even light years in principle, if you wanted to.
But how? But you need to fire like a light in the direction of the two slits. So how can you have them
So-
separated by so much? I mean, I'm just trying to imagine. I'm
Yeah, so
just
just
trying.
you
Mm-hmm.
yeah, you just use a light source that is, sufficiently positioned in such a way that you're only sending photons down to your targets.
Okay, so are you
I
using
mean,
a
it's the
beam?
question. Your question is like, how do you shoot a light beam through two slits that are separated by meters? It's like, well, just you point it that way. What's the hard part?
Like with a beam splitter?
No.
Okay, I have a laser pointer, right? That's not gonna work, right?
Laser pointers are typically not used for this because you want individual photons, and lasers do not work with individual photons.
Okay.
Why not? Do they put one big photon out?
What you want for this single photon experiment version is a light source that is very low intensity, such that you can basically just get individual photon emissions.
Oh, so you could use a laser and filter it and filter it and filter it until you had the rate you
And
wanted,
just
right?
put it through a sieve.
That's amazing, Jesse. I wonder if somebody could have done that.
So what is the light source for when the two slits are meters apart? I don't get it. What do you use?
I think they use a low intensity thermionic valve.
Okay, and in English, what is that?
On the retroencabulator?
It's basically a vacuum valve, vacuum tube, run at very low power.
Is that the precursor to the turbo encabulator, Lesnar?
No, it's the thing you used to have in a radio back before transistors.
Does it emit visible light?
Yes.
What color?
It depends upon the temperature.
So it emits a single photon?
You can apparently tweak them in such a way. I'd have to check the exact type that
You don't know what a vacuum tube is, Mr. Slave? What?
Evidently, he doesn't.
So it's a vacuum tube?
Yeah.
Or a valve, if you prefer the British version.
Yeah. The stuff we used before transistors, you know?
Wait, isn't the vacuum tube?
Cool that
Doesn't the vacuum tube emit electrons?
It allows the flow of them. You can control the flow of them. It's like a shitty transistor. It produces a ton of heat.
Yeah, but it gives off electrons, not photons.
It doesn't give off electrons. You flow electrons through the vacuum tube, and you're able to shut it on or off. It's a shitty transistor.
So
in the single light experiment, they used a thing called a BBO crystal.
A BBO crystal to what?
As a source for the light.
How is a crystal a source of light? Like they heat up? Why is it?
Yeah.
But why do you need? But why do you need such a strange source of light in order to do the double slit experiment? I don't get it.
Because you want it to be able to emit photons of a certain wavelength, but an extremely low intensity, meaning they're very low number of them.
Mm-hmm.
But couldn't it be argued that a non-coherent source like that depends on the random-ish capturing of electrons by molecules or atoms could create kind of an already quantum light pattern, as not only in timing but also phase angles and stuff, that maybe it's not, I mean, if we're basically using a quantum technique to produce the light, and then we're using a quantum technique to detect the light. How do we really know that it's the light itself that's quantum, or just our production and or detection methods, right?
You lost me there with halfway through the question.
That's a bad sign. That's a really bad sign. Do you even know what we're talking about?
Anyway,
Sorry.
okay. Anyway, so so you're saying we're using a valve in order to create low intensity, very few photons of a visible light, and then okay, and then you have two slits meters apart, yet you're able to make sure that it's basically only one photon at a time being emitted, and then you're seeing the detection, and you're getting a double slit, and you're getting an interference pattern. I need to see it. Anyway, but do you have any links to that experiment, to anything, any more
Dude,
information?
Falcami literally posted a link to the paper,
Let me see.
and then he posted it again.
What's the
Maybe
name?
he'll post it a third time.
Falcami?
Here you go. Here it is a third time.
Okay. Video. No, the one that's meters apart.
I never said that I had an experiment that's meters apart, because it is not practical.
So how do you know it would work?
So Troy's lying. Oh my god.
So how do you know? How do you know meters apart would
Dude,
reproduce?
you're literally trying to deflect away from the problem. Your problem is that even with the real experiments, which are gap spacings of millimeters apart, which is still way larger than the wavelength, you have no explanation. So let's focus on the thing that we have experimental data for, which you have no explanation for.
Look,
then we can quibble about other theory.
Fine, you brought it up. I'm
I
trying.
said the principle.
Fine. All I'm
applies.
saying, I thought that was an actual experiment, because I wanted to go like to the hardest question. What's the point of dealing with an easy question? I want to get the hardest question.
You already can't answer this question. So let's go with the one that we have experimental data for.
I mean,
and then we can.
So what honestly,
generalize.
okay, so what's the question right now? So you're firing, okay, so in a real double slit experiment that you want to discuss, tell
Yes.
me, okay, and let's go through the data. So were they using for light source like a laser, a red laser, or something else?
Yes.
Red laser, okay.
They're using that BBO crystal stuff.
The BBO crystal, okay, so visible light, very low intensity, so very few photons, basically one at a time. Each time they were getting only one detection, and they got an interference pattern, and it seems like the photon went through both slits, but when it decided to interact with an electron, it collapsed, it got snatched up by a single electron somehow. An electron sucked it up, which is
or sucked it off, if you want to use that terminology.
Right.
It really doesn't matter. It interacted with a single electron. It interacted at a single location.
Which is weird. I mean, it's not a location. I mean, it is
weird. Yeah.
Yeah. Okay, fine. Yeah, it's weird. I mean, it's not a point. It's still a region. It's still an orbit. It interacted with an entire electron orbit, and it pushed it up. But the question is, something so big that can go through two slits simultaneously suddenly interacts with I think like
only one spot.
It's like the size.
It trips only one pixel on the CCD. That's the trick.
Which is an electron, which is a single atom. So a single atom, we don't even know if it's a single atom. You know what? But it's even if it's a region, it's even worse. how do we know? Like a CCD pixel, is it a single atom? I don't think so. What is it? What is a pixel?
It's a single light detecting device.
Right, but what is it? I need to know the mechanics. I mean, it's better. We look for a good analysis. We need all the data we have.
It doesn't matter what it is, as long as it is smaller than the separation, and we know specifically that it is. It's only basically one spot.
Okay,
It interacts only in one spot, but it goes through both spots.
Well, we could go over what it
Right.
is. If it's a CCD, it's an electron well. It's basically a photodiode coupled to a capacitor, and every time a photon hits the photodiode, it pushes an electron into the capacitor, and it's called an electron well.
Yes, but it's the smallest detection unit that the CCD can detect. And no, it's not a single particle or a single atom or a single electron, nothing like that.
So can you explain again the mechanism of the detection?
Dude, research what a charged coupled device is.
Charge coupled device? Charged?
Yes, that's what that's what the word or the acronym CCD stands for.
Okay. Charge coupled device is a light sensitive integrated circuit. It captures images by converting photons to electrons. It consists of a layer of insulation over substrate with electrodes or taps along the insulated materials. When properly binds these electrodes from potential wells where charge can be stored. Okay. I'm going to need to watch YouTube videos about this. Anyway, so what are we
How
assuming?
about you read a paper about it instead of watching YouTube?
I mean, it doesn't matter what I do until I'll do whatever I need to do until I understand enough in order to feel comfortable that either I have an answer or I don't have an answer. So the question is, okay, so it goes through both slits. Look, that I don't know if that has anything to do with the wavelength. I mean, the way that I mean, the photon.
Well, the sizing and the separation of those slits has to be matched correctly to your wavelength, because otherwise you're not going to produce a diffraction pattern and an interference pattern.
Okay, but I'm saying the way the photon works, right? It goes up and down or whichever way, and 90 degrees to that is the magnetic wave. So
it's not just a wave, though.
What do you mean? What do you mean it's not just a wave? It's an electromagnetic wave.
It's also a particle, though.
I don't know what that means.
Well, it means that if you fire a beam of light at a photoelectric, you can kick electrons out of the orbit. It has momentum.
Yeah, but that's not a particle. You can have momentum. No, and the way, if you read Maxwell, you see that the EM wave has momentum without being a particle. So Maxwell agrees that EM has momentum, so you don't need a particle for momentum, according to Maxwell. So anyway, you have.
So they act like particles, but they're not particles.
They don't act like particles. There's
They
no.
act like particles. Yeah, they do act like particles.
How?
They're individual. When you fire them at the double slit, they're individual.
Yeah, they have one definite location. They do not spread out. But before they impact, they did behave like they were spread out.
Right, but they hit as individual particles, but the particles are in the waveform. It's like a
yes.
Okay, but the way I see it, nothing was moving through space except for the propagation of the energy was moving.
Well, right, but we fire an individual particle, We notice an individual particle hit the detector. In the meantime, though, it behaved like a wave.
Right, but at no point was there a particle. It's not a
Well, wait a
particle.
minute. We fired a particle out of the gun. We noticed the particle hit the detector.
No.
Get in between, it acted like a wave.
No. You never fired a particle. You never
We did. We fired a particle. We fired an electron.
No. We're talking about a photon.
A single electron.
We're talking about a photon right now.
Let's ignore NASA. Let's not talk about how we emitted a single particle. Let's talk about the fact that we only detected one particle on the other side.
Okay.
Yet they
Yeah,
all
that works
behave.
too.
Yeah, yet they all behave as if they were a wave that was spread out.
Okay. Look, the only question is, all the information we have is that it's a wave. At no point did we detect a particle. The fact
Incorrect.
that wait, let me
Well,
finish.
we detected an interaction only at a single spot on the detector. If you want to call that a wave packet, be my guest. Wave packet in your language is just particle, what we call a particle.
Okay, so hold on. So it's weird that we detect a single pinpoint location, but that is
It is.
Why?
Yes,
Why is it
yes.
weird?
Let me just finish.
I mean, it's weird, but it happens.
Yeah, hey NASA, Totoro's got this. Can you give him some room? Give him a free line. He's doing a very good job. He doesn't need your help. Thank you.
Yeah, NASA being a cock as always.
Anyway, look, my point is that even with the weirdness, even if I would submit that there is a weirdness to the collapse of the wave, but it's still
Function.
wave.
Sorry, I
Even
was just completing your what you wanted to say there.
okay, I don't agree with your completion, so I'll start over. So even if I agree that there is a weirdness that the wave
NASA, shut the fuck up.
collapses into a single location, that is still not my definition of a particle.
Sure,
So-
sure, that's fine. If you want to define terms differently, that's okay. We're just gonna say that the wave collapses into a wave packet, where a wave packet is what we normally call a particle. That you call it wave packets. Let's use your terminology there, wave packets.
No.
So we fired an individual wave packet.
Let me just
It goes through both slits,
Let me-
and we only detect it as a single wave packet.
hold on. No. You're misexpressing the way I would express it. So let me express it. But before that, let me tell you the importance of the distinction. So I never had a position about quantum mechanics, GR, SR, anything. I never had a position. I wasn't in this universe. It was not my place. I research other fields. Anyway, until 2-3 months ago. So 2-3 months ago, I came to the realization that there is ether, that ether comes out of Newton's equations of gravity. And once I realized that, I couldn't figure out how there could be particles in a universe where ether is flowing so fast.
You're not really trying to explain the double slit experiment. Anyway, I gotta go here. It's past 4 a.m. for me, so
Oh.
have somebody else have fun with them for the rest of the day.
Good work, man. Sleep well.
See you, folks.
Thank you, Totoro. Thank you for your time.
Jekyll, are you here?
Thanks, man, for the chat.
Jekyll, coming in. Jekyll.
Did Sea Lion talk to you guys and ask you to finally be productive with me?
No.
No.
He didn't.
Oh, God. Pin a ticket on yourself, champ. Wow. You think we just obsess about you? You don't live in our head rent free, mate. Don't even kid yourself in that department.
Mr. Slave has been living in my head rent free.
You're kidding. You might
Yeah,
let me.
speak for yourself. Speak for yourself, Bula.
Okay. Well, geez, you guys give away free rooms.
Look, the point is that even if we somehow realize that there is a weirdness to the collapse of the wave, that still doesn't mean that there is a particle wave duality. The collapse is weird, but that could be just the way things work. We can work out the details.
Just the way things work. Kind of like, magic.
Sea Lion, I gave you an option. I just heard NASA speak. That's not good. It's not
Why?
good. We can't have that in that server. We can't have this in the server anymore.
Ban NASA.
Ban NASA. I agree.
What's
I'll
going
pay you
on?
$50. That's negotiable.
Let's give him a word quota. We'll give him like say 500 words per day, and once he exceeds that
Okay,
limit, that cap,
That's
he
reasonable.
gets muted. What do you think? Does that sound like a good one?
No.
That sounds like a NASA conspiracy to me.
Anyway,
So,
Okay.
NASA Shill, if they're gonna ban you, there's a place in my basement for you. So you'll always
that's
have a
okay.
home.
That's okay.
It-
I mean,
It might have leather, and
anyway,
there could be chains,
anyway,
possibly some silicon.
not,
But
not
it's
my
your home
kink.
now.
anyway,
Don't
Not my
threaten me
kink.
with a good time.
listen,
And
listen,
Really
guys.
not my
Forced
kink.
homosexuality.
Anyway, listen. So we've had this discussion. It's a good discussion. So the discussion. Let's rewind the discussion, or repeat, or coalesce, or bring it back home. What did they say? Like, let's review, regroup. I don't know. There's one of those words. Let's go over
Debrief.
it. Retrieve,
Debrief.
debrief. Yeah, but there's one more word we're missing.
We need an after action report.
That's multiple words. Anyway, look, the point is that the discussion began with the definition of science. So my definition of science is that the universe is under an obligation to be understandable, understood, mechanical, simple,
No.
intuitive.
No, it's not. I'm sorry, but it truly is not.
Yeah,
Your
yeah.
senses.
Yeah. My definition. My definition. That's my
Mr.
definition
Slade.
of science. Yeah.
Okay, so with that definition, what predictive capabilities do you have with that definition?
Well, I'm not gonna give up on quantum mechanics and just say.
That's not an answer to my question.
Well, that's
not
what
an answer to my
happened. That is what happened.
No. I want to answer my question, Mr. Slade.
Namely,
Yeah. My question being, with your definition of science, what real world predictive capability do you have? Like, can you tell me how something works? Like, could you empirically determine whether a drug works in a group of people or not with your capability of science, with your explanation of science? Because it doesn't really sound like it.
I mean, theoretically, by my definition of science, I should be able to explain any phenomenon in the universe mechanically, intuitively, so that a child can understand it. That's my assumption. That's my working assumption.
Like I said, pretend we're children and start explaining.
Well, I mean, that you saw how I went through the double slit experiment.
And blew it, but that's okay.
How did I blow it?
You wouldn't have done much better, NASA. Shut up.
Well, no, I would admit that they're particle wave duality.
What indication do you have that an elementary particle behaves like a particle?
Well, we fire individual electrons at a target,
But
and we see individual particles hit the target in a waveform.
Compton scattering. I mean, there's a bunch of them. You can go look them up. But I have a solution to the particle wave duality.
What's that?
Behold the warticle.
Anyway,
so you want to what's your favorite interpretation that is not Copenhagen?
It's warticles warticling.
Anyway, NASA NASA
As
shell.
you can see, it's unbeatable.
Wait, are you showing
Yeah.
something?
Can
Is
you articulate on your article or not?
Can I what? Say
Or is it
again?
Can you articulate or is it article analysis? Which way are you going to article this?
Are you
Well,
joking, or is somebody?
A article is a term for a new element of being that is both wave and particle at the same time.
No, so there's no particle. There's never a particle. That's what I'm trying to show you. There's no particle.
There are particles.
Okay,
Don't
NASA
spiral.
NASA shell.
Stop
Let's
spiraling, guys.
That's why we can knock electrons out of the orbits on the photoelectric effect.
one second. Okay,
What I really want to know is what Lael thinks about this, because it's Lael's joy. Lael, can you explain the wave particle duality to Mr. Slave?
It exists.
Yeah, come on, Lyle. You can do it.
It exists, and there's nothing I can explain more than that.
All right, let's get back to NASA shell. NASA shell. So, what's your evidence? Tell me one piece of evidence that, let's say, an electron is a particle. What evidence do you have that an electron is a particle? One, only one.
What?
The behavior of photons interacting with electrons in Compton scattering.
1 second, Omnivore. Me and you have been through this multiple times, but NASA shell, I don't know if that's the evidence he wants to present. So NASA shell, present to me, please, your best piece of evidence. And Omnivore, we can do this again, but right now, NASA shell.
Okay. All right. If it's not, it should be. Okay.
Yeah, sure. But NASA shell, give me your best piece of evidence that an electron or a photon, pick one, is a particle. Just one piece of evidence, please.
Photoelectric effect.
The photoelectric effect. Okay. So the photoelectric effect, you have a photon raising an electron out of its orbits all the way until it frees the electron, right?
Yep.
Okay, so a photon is just a wave. It's a wave packet. It's a wave.
Photon. Nope. Sorry, it's not.
Okay, so look, if I'm able to explain your evidence,
You're not. You're not going to be able to explain it. You're just going to be able to think you explain it, because.
We'll let him try.
Okay,
Just
all right,
let
that's
him
true.
know.
Go ahead and try.
Thank you. Look, but my point is, look, so when I debate, my theory of debate is as follows. I'm not here to convince you. I'm here to stress test my theory.
I'm not here to make friends.
Yeah, I'm here to make friends too.
Tested Mr. Slave. We gave you all that criticism in your document. Didn't you react to it? That was the stress test.
That was a stress test to my personality. Anyway, NASA shell. So look, when you present to me, when I tell you hit me, when I ask you to hit me with your best shot, I'm literally asking you to hit me. I want to see if I am strong enough to deal with your evidence. So it's for me. So I might as well take your shot and leave the room and deal with it and never tell you what the answer I got is. It's not for you, it's for me. So
well, you can't explain the photoelectric effect using just waves.
To me I can. So if you want to hear me explaining,
Well, to you can, but you think that everything's. I mean, you're sort of in your little mind loop, projecting all the data that disagrees with your preconceived conclusion.
NASA shell. So look, if you want to listen to me explain to me, I'm going to now explain to me the photoelectric effect with only waves. You're welcome to listen to it and you can accept it or not, but the point is I am very comfortable with it. So here it is. So
I like to watch. Go on.
So a photon is.
Hey, excuse. Before you do this, could I ask you your background in science? I mean, you obviously have a doctorate in physics, right? Particle physics.
I'm going to ignore that question. Let me.
No. So really, I mean, what did you go to school beyond the 5th grade or?
Okay, NASA Shill. I never ever.
Why the fuck has NASA Shield not been server muted at the very fucking least?
No, I just want to know his background. He's
No,
obviously
no.
he's obviously
Because
a genius here.
Clearly, NASA Shield, shut the fuck up. Doesn't work.
Well, he's
Jesus.
obviously a genius here. I was
Jesus.
just wondering if he's like Goodwill Hunting or.
It's just
or what?
ridiculous. I don't understand how this works. Like, you talk, everyone says shut the fuck up, and something in your brain says talk more. It doesn't even make sense to me.
Dying.
Oh my god! Oh my god!
I'll do reverse psychology then. Keep talking, NASA.
Yeah,
like,
talk.
what does it take for you to understand to shut the fuck up?
Oh
I
my
don't know his
god!
science background. He's obviously a genius here.
No, so
I like
apparently you
this.
just won't understand.
I like listening to NASA. So he's got very good insight.
Oh my
I like
god!
when he shuts the fuck up.
Because I'm so
It's the best
genius.
insight he could provide.
Like be genius.
Well, I mean, he's got a conclusion here that's obviously a Nobel Prize winning. I mean, he's obviously going to upset
You're still
all we
talking.
know.
Why?
No, he hasn't told me the answer.
No, but yeah, because no one should talk to you. You know what, people? It is every time you respond to him, it's your fault too.
Wait, what?
If we all just ignore him,
Ignore
maybe
me?
he'll learn to shut up. No, NASA.
Oh.
If we ignore him, maybe he'll get the point. I doubt it,
Maybe.
but it'll be worth a shot.
Well, until that, Mr. Slave can tell me his background in physics. I mean,
Jesus Christ, you just don't shut the fuck up.
Look, NASA Shill, I'm not going to respond to that question. I don't.
so the answer is you don't have a background in physics, yet you
See?
say,
Still,
yet
repeat
you talk
yourself.
like
It's
you do.
Repeat and rinse. Like, just shut the fuck up.
Master Shield's not here to fall in line. He's here for a mission.
Yeah.
I just want to know his background in science. That's all.
Simp for everybody. I don't understand.
Look, NASA Shill, I don't talk about myself. I only talk
Of
about.
course not, because you're an idiot. I'm sorry, but you're
Jesus
talking
fucking
like you're from the
Christ.
15th, the
Seriously,
19th century
like,
at least.
NASA, can you mute yourself?
Sean, go ahead and insult me all you want.
I'm not. No. This is actually just a question. Can you mute yourself? Like, is your mute button broken?
Anyway, NASA Shill. So, given that I'm not going to respond to your question, so what?
Why not?
That's a given. I don't discuss
Are you
myself.
ashamed? Are you ashamed of your background? You
I
realize you
don't-
don't have a background,
I
and you're
don't.
talking out your ass.
I
Oh,
don't.
incoming mute.
NASA, I don't discuss.
Boomer, we know you can count backwards from 5.
NASA, I don't discuss myself. Given that I
Of
don't.
course not. You don't have a background in this subject. You
Oh my-
talk about it like you do.
Shut the fuck up.
You don't want to get muted by Boomer, NASA. You know he can count backwards.
Watch out. Terry's going to do it and blame me. Yeah, I know your trick, Terry. You're going to mute NASA and say it
Wait,
was
time
me.
out. Are you motherfuckers mods here and you're allowing NASA to talk? You're the problem.
Oh my god.
Look, now I can talk because NASA's
Wait.
not talking.
Wow.
Boomer, what did you mute NASA for?
Oh, dude, what did you mute Sean for? Oh, that's not very fair.
Anyway,
I don't
okay.
mind- I don't
Well, anyway,
mind
Mr.
shutting the
Slave,
fuck
I mean,
up.
you've got an interesting hypothesis here, a theory that links it
was
all
NASA
together. I'm
talking the whole
wondering.
time he was muted.
No, I wasn't actually. I've been unmuted for a while. I was just wondering if you could explain to me the experiment, the background that you're basing all your data on, please, because you're obviously a genius, much smarter than anybody else in this room.
It's already been established that he is. He doesn't have to go back to square one with every new glober in here. Ask your peers.
Look, NASA, let me just answer because I'm not going to talk about myself. I'm just going to talk about the photoelectric effect. I'm going to explain to you.
So the answer is you don't have a background in
You
science,
have
but you're going to
shut the
continue to
fuck
probably
up
like you
if
do.
you're gonna let him. If you're gonna ask him a question, shut the fuck up so he can at least answer it.
Anyway, so let's talk about the photoelectric effect quickly. It's really very straightforward. So the photoelectric effect says that we have a piece of metal and we shine on it light. and nothing creates a current. Well, we're detecting electrons, and once electrons flow off this filament, this metal, then it closes the circuit and we detect a current. That's the photoelectric effect. And they discovered that only ultraviolet light creates a current. So you shine ultraviolet light, somehow it dislodges electrons from their orbits, from their metallic atoms, and they fly off and they go into the cathode, whatever, and closes the circuit, and we get a detection of current. So Einstein said, well, that proves that it's a particle or whatever. So I don't know what Einstein meant. I'll explain to you everything as a wave, but as a wave packet. So a photon is a wave packet, meaning it's a wave. It is waving through the ether as it's moving through space until it gets to an atom, like the atom that we're trying to dislodge its electron. So each electron has energy that is based on its frequency, and the frequency is the light. So only ultraviolet energy is high enough equals FH. So only ultraviolet frequency is high enough to create the energy in order to pick up the electron all the way from probably the lowest orbit or whatever, wherever it is, all the way up to dislodge it from the atom. So certain waves have too low of a frequency, but certain waves, meaning certain photons, have high enough frequency and higher than that. So it's either ultraviolet or I think after that is X-ray and gamma rays. Anyway, smaller and smaller lambdas, smaller wavelengths have higher and higher energy, so that when they come in contact with the electron orbiting, they endow the electron with their energy. They somehow get swallowed into, I think they just impact the electron and push it out. And they get dissipated into the into the ether fields. Anyway, the photon is then gone. It's been swallowed in, and it dislodged the electron. But it always was a wave. There's no particle. Nothing moved through space. There was only a wave, and a wave waving through the ether is not a particle. There's no particle in the discussion. Questions?
Particle.
Yeah. Questions?
So
yeah.
So what you're doing, Mr. Slade, is you are denying that there is a particle style interaction.
I mean, I'm explaining to you at least half of the photoelectric effect.
Yes, but
half, yeah.
If that worked, then Einstein wouldn't have won a Nobel Prize for it or whatever he won.
No, I mean, even if Einstein said look, he didn't know what I know. I know what he knew plus 120 years or so. So that's not fair.
Yeah.
But whatever he said, whatever he said was enough to, to resolve it. My definition, one of my definitions of science, proper science, is if you are able to peel one layer of the unknown onion at a time. So if you've done that, if you've peeled a little bit of the onion, of the unknown onion of the universe, then that's it. That's science. So he peeled it enough, but it's only half of the experiment. There's another half. I just don't want to bore everybody to death. But this
You've already
one,
done that.
What?
You've done that.
Yeah, I'm sorry. So the other half would have been even more boring. So anyway, but if anyone was able to follow, so I'm able to tell the story of the photoelectric effect
No, sir, you're not though. It's not doesn't work that way in classical. Sorry.
You know, I can hear your teeth moving.
I don't mind you telling me a story. I'm due from the afternoon nap.
NASA, you're like 90?
No,
Do you
what?
do party, mate? Do you do party?
Like,
Are you like 16 or what?
No, but I can hear your teeth moving.
It's
Oh.
okay. We all get old one day. It happens.
Yeah,
to all of
except
us.
that maybe it's because I'm holding my hand on my chin so that I don't fall asleep with listening to your explanation.
Oh, that's the noise.
That's precisely what I'm doing.
Anyway, NASA, I
Except I'm gonna
just
fall
wanted to
asleep
say
anyway.
I appreciate your interaction with me, because you're like one of the only ones who's actually like you're actually having a factual discussion with me, which is amazing.
Never heard the word yeah.
There must be a better word than factual.
What you
I
have
was
to
thinking of
do-
another word for interaction because I've heard other people say different words.
The thing you forget is that this absorbed light that you're calling in wavelengths is absorbed at distinct quanta, what we call photons. Not at some sort of wave, but at distinct little quanta.
Right, but this quanta is the wave itself. Look,
No, it's not a wave, sir. It does not act like a wave. It acts like a distinct quanta, a distinct little package, a little particle, if you will.
well, it's a little packet. Look, okay, you tell me, how exactly, right? You have an electron orbiting the nucleus of an atom.
No, not really. That's
so. So you tell me this story.
They're actually out there in some sort of space, in some sort of in an orbital. They're kind of there. It's like a cloud of probability, and then
Look, you need to tell me the story. Right? Einstein told us a story of what happened.
Einstein won the Nobel Prize for this. He did more than tell a story. The Bohr model doesn't work beyond hydrogen, and it doesn't work really well for hydrogen either. You have to get into you have to get beyond Bohr, who's like what 120 something now years old.
Look, whatever you want, you need to tell me the story of, even if you want to tell me that a photon is a particle, that's fine. You need to tell
It
me
can act like a particle. It's not really a particle. It's not really a wave. It's sort of a combination of both.
Whatever.
It's neither. Both, however you want to look at it.
No, it's not. Not however I
Doesn't
like.
logically compute.
I know it's tough to understand. The universe is under no obligation to make sense.
Well,
Then you just admitted that your story makes no sense. So
No, what I'm saying is what I'm saying to you is that your senses are not necessarily tuned enough to understand quantum mechanics. This is not, you can't like touch it. You can't like see it. It works. It works well. We've used it for over 100 years now.
Okay.
The very device that you're currently on, if you're on a computer or a phone, relies on quantum mechanics. Relies because of the transistor, which is quantum mechanics, lasers, all this stuff, quantum.
Okay. So your first part, you were referencing me, and I told you I don't get referenced in discussion. So
We should, because you are either.
All
you're
right,
either
chill with the
brightest
personal
guy-
attacks. Let him respond.
No, not a personal attack.
Let
He's
him
either-
respond. He wasn't
No,
done
stop,
responding.
Stop! I don't give. Okay, stop
All
trying to
enjoy your
moderate.
server, Glover.
Stop trying to mod.
Enjoy your
You're not a
server.
mod here. Stop trying to mod.
no, but NASA, you do cut me off often. I never cut you.
Well, that's because you don't shut the fuck up. I let you go when you went on a tirade for about 5-10 minutes.
Who doesn't shut up?
You were saying NASA? That is a very bad. Shut the fuck up, NASA. Where do you think that comes from? Because you don't shut the fuck up.
Anyway.
Sean talking about me again. I can see him light up.
Anyway. No, I heard your teeth this time.
Well, say what you want. I don't give a shit. My teeth are quite well. Thank you very much.
I heard you biting your teeth into place. It's not
Or
just
you can say whatever you want. I don't give a shit.
Look,
My
I'm not.
teeth have nothing to do with this.
I'm not
Your
judging.
mind, on the other hand, you're either the brightest guy here and should win the Nobel Prize for physics, or you should go back to school and start about, I don't know, college level, I think.
Okay, this time it was your hand and your chin, but before I heard you.
What? No,
biting-
my hand is nowhere near my chin. You can talk however you
I
want.
mean, on your
go
cheek.
ahead and deflect. Go ahead and deflect all you want.
Yeah, don't be hypocritical, Slave. You were mentioning before where you didn't want to talk about personal thing with you, and you're bringing up personal thing with NASA. So that's, I wouldn't be doing that.
No.
Yeah, good point.
No. I'm not inserting NASA into the conversation. Like like an ad hominem. Like I'm not making an argument from his person. I'm just mentioning that I can hear his teeth. That's all.
Well, good, say whatever you want. I don't understand what you're talking about.
That's, hang on, Phil. That's a personal attack, Mr. Slave.
No.
I mean, for someone so smart, yes. You seem to
No.
be missing out on a very basic piece of information. This is 5-year-old shit. So you're not that smart because you don't know a personal attack. That's personal. Yeah.
No, I'm not attacking him.
He could be sniffling. He could be stuttering. He could be coughing. He could be doing any other noises. It doesn't matter. That's still personal.
No. It's personal, but it's not an attack, and I'm not making an argument from his person. I'm just mentioning I can hear. Look, I asked him if he's 90. He sounds like a very nice person. I'm just trying to be nice. Like I'm having a conversation with him as a person for a second. I didn't mean to be mean or to attack or to argue from his person. Not at all. Not at all. That I would never do
You
that.
say you apologize. And you say you apologize. Is that the
I apologize if I hurt anyone's feelings ever. Of course, I apologize.
Listen, stick to ether. All these guys want to do is attack you and your character. That's all they're here for. Just stick to that information. Don't try to get these guys to like you or be on your positive side. That's just how it has to be.
Yeah, we're done. I'd appreciate some evidence.
is what it is.
By the way. If you're going to invoke Aether, you need to give some evidence for it.
Anyway, look, I explained the photo, at least half of the photoelectric effect, as a story that makes sense, that is mechanical, intuitive, so that a child can understand it. And I can do this.
And it's wrong.
And I can do this.
He keeps saying that, and I still don't understand it.
Then ask me questions. What's the question? What don't you understand?
Well, if it's a wave function, then it should behave according to classical physics, and it doesn't.
I just explained the photoelectric effect as a class.
It's not classical. Otherwise, you run into the problem with the ultraviolet catastrophe. You won't get individual.
Hold on.
You
Okay,
won't get individual. You won't get individual. You won't get in. You won't get individual. You won't get. You won't get. You won't. Okay, go ahead and overtalk me. I understand. Yeah, I'm gonna get blamed for this. Now Sean's gonna yell at me because you're overtalking me, but that's the way he works.
Anyway,
you won't get in. You won't get individual electrons out shining when you hit them with individual quanta.
Okay. I just explained to you the photoelectric effect.
No, sir, you did not. You thought you did, but you did not.
Then ask me questions.
How does it work? It doesn't work like that. You cannot shine a wave
What's the
function
question?
on this and get individual,
Individual
electrons to kick out.
Ask me a question.
How does it work?
I just finished explaining. Ask me a question.
No, you didn't, sir. It doesn't work that
You
way.
want me to? That's not a question. Either you ask me a question, or I don't know what to say. So, ask me a.
How do you get individual electrons to come out? It shouldn't work that way according to classical physics.
Okay, so are you asking me? So, look, I can explain to you how the photoelectric effect works in my mind.
Or so, in other words, not in reality, but how your straw man of it so that you can explain it according to classical physics. And by the way, in violation of
One
what
second.
Einstein said and won the Nobel
One
Prize
second,
for,
one
but you're
second.
smarter than him, so that you can
One
come up with
second.
the explanation according to classical physics, right?
Okay, so look, the debate started from my definition of science. So I said the universe, according to my definition of science, the universe is under an obligation to be intuitive, simple, mechanical, so that a child can understand it.
Well,
So,
unfortunately,
hold
quantum
on.
mechanics is not
One
that way.
second, one second,
Unless
one
unless
second.
you have
Let me
suddenly some
finish.
sort of
Please let me
some
finish.
unless you have some
Please
sort
let
of
me please let me finish.
unless you have
Please let
some
me
sort
finish.
of
Please let me
unless you have
please let me
unless
please are you
unless you
please
have
let me finish.
unless
Let me
you I'm
finish.
going to start. I'm going to
Let me
finish this.
finish. Let
I'm
me
just as
finish.
stubborn as you. I know
Yeah.
Sean gets
And
upset when
Mr.
I do
Slade,
this.
his ultimate weakness
know,
is to mute
I
him on
know.
your end and
I
tell
know,
him
I
that
know.
you
Go
muted
ahead and
him.
overtalk. Go ahead and
shuts
talk me
down
for a while.
immediately.
Go ahead and overtalk me for a while there, Glory. That's good.
Yeah.
So unless you
Okay,
have some
Glory,
sort
Mr. Slave. Glory, still Mr. Slave. This is really painful. This is like pulling teeth to listen to. Can you three please just grow up? That's all. But grow up.
unless you have some sort of new evidence, some new experiment that will
One
explain this
second, but I was in
classically.
the middle of speaking. You cut me off.
Yeah, so you've got some new evidence.
cut
You have
me-
some.
you
You have an
cut me-
experiment
you
that will
cut
show this.
me- You cut me off in the middle, mid
So you have an experiment that will show this, demonstrate that what you said is
Okay,
true.
I'm leaving because I don't want to waste my time. So,
So you don't
I'll be
have
back
an
later.
experiment.
Oh my god! I thought I was talking. It's like every time you think you're talking to a normal human, and then you realize, oh no, it's not a normal human. Oh, time out. Paul Veron clips timeout. Oh my god. Oh my god. Anyway, at least it's good content. Quantum mechanics. Oh my god. What's why? Oh, mechanic. Quantum mechanics. Oh my god. Debates about quantum mechanics. Oh my god. This is good content. Oh my god, this is good content actually. Come to think of it, it's good content.
Waves create the same types of interference patterns and would work in a double slit experiment the same way that laser light would, right?
Go on. I'll just have to take your word for it.
Okay, no one disagrees. That's good enough.
Wait. That sound waves will work the same way laser light does?
Yes.
No, I don't think so.
Wait, what's
Think
the
about it.
question?
If you have, let's say you have two speakers putting out the same frequency in phase.
Wait, could you repeat your thesis before you go into an
Why?
example?
Just listen. We're all listening, Mr. Slave. Just shut up and listen.
No,
Like,
I can't. I went out and I just came back. So
Yes, he's presenting. We got to go on mute and listen to him.
Yeah.
He's presenting.
Yeah.
So someone else came in when you went out, Mr. Slade.
yeah. But could you restart?
All right.
Yeah. So anyway, if we try to picture two speakers, like, car speakers, car radio speakers, say a couple feet apart in a room, each playing 1,000 hertz tone in phase, same frequency. They will each be putting out a wave that will travel and hit the wall on the opposing side of the room. And depending on the location on the wall, those waves will either be in phase or out of phase. And where they're in phase, they will be constructively interfering. And where they're out of phase, they will be destructively interfering, and the sound pressure level will be less. And so if you were to actually map out the sound pressure level at every point on that wall, you would find the traditional double slit interference patterns, right? Are we good there?
Yes, I agree with that.
Yeah, I agree.
Okay, good. All right. So let's say we had a budget that I don't. Actually, I've thought about doing a GoFundMe for this because this would be really fun. But anyway, let's say we bought 10,000 little microphones and microcontrollers and RGB color LEDs. and we made a whole bunch of sound pressure level sensing pixels. They would each light up the LED based on the sound pressure level.
Okay, that's really boring. Let's see this. Video recording, true single photon double slit interference. Very interesting. What's this? Let's check this. Check it. This guy, I don't know if I like him. Serial abuser, Christian Prince, fact check why Lebanese and Syrians celebrating Nasrallah's death. Yeah, the American leftists don't want to hear that. Oscillations. Wow, there's so many great videos that I want to listen to. Wow.
Law F equals ma, meaning that a particle with
you can't get.
To describe a particle's motion, we can use Newton's second law F equals ma, meaning that a particle with mass m gets the acceleration a if a force F is exerted on the particle. But this is not the case in quantum mechanics. In quantum mechanics, we use the Schrödinger equation to find a wave function of the particle which contains all the information we need to describe it. The wave function is not a physical wave, but acts like one.
That's nonsense. Yes, it is. It's a physical wave.
And psi squared gives the probability of finding the particle at position x at time t. To describe a particle's motion, we can use Newton's...
I don't know what that... I don't know. Don't know. Anyway, I think I'm gonna go. Yeah. I think I'm a little bit tired. I mean, I could do some math, a little bit of math.
M31, M32, M33. And you'll notice that essentially I've got I rows and j columns, and each element can be written as Mij. So if you take this element here, it's the second row, first column, so it's Mij, M21. Take this element here, it's one of these values. I do it, you're absolutely right. We simply take the complex conjugate of each element in the matrix as being complex of the matrix. Again, what that means that if... Now I'm going to introduce you to the transpose of the matrix. All you do here is you interchange rows and columns, the diagonal rows. So MT now becomes M11, becomes M12, M22, transposed with the columns. You'll notice have interchanged, they transpose. Combination of these two. It's both a complex conjugate and a transpose. So first of all, we have to take the transposed matrix, M33, that's the transpose matrix, that's just that. And now we complex conjugate every conjugate of the transpose, which we represent as M dagger. So in other words, what's happened here is Mij of our original matrix has become Mji complex conjugated. And now we consider a situation where M, the matrix, equals M dagger. And let me give you an illustration. If M is equal to, and I'm only going to do a two-dimensional matrix here at the same time, this is the matrix. It's got 4 elements, 2 rows, 2 columns, 1 plus I, 1 minus I, and 3. What is M dagger? Well, remember, M dagger, you have to transpose about the diagonal and complex conjugate. The diagonal doesn't change. So the 2 elements of the diagonal don't change, and anyway, they are not complex numbers. 1 plus I has to move down to here, but it also has to be complex. Notice that M equals M dagger. When that happens, the matrix is called permission. That means that the matrix is equal to its transposed complex conjugate. I'm afraid we need to continue with the maths a little further, because now we want to ask what happens if we have a matrix and we apply it to a ket vector. M22, that's the matrix. The vector is A1, A is you take, and that is the bottom line. I'll do that again. M12 times A2, that's the top. That's all just one number. So that's the top of our new ket vector. And this one is that number, A2, but none of... I need to introduce you to what is called the identity matrix, a matrix to very likely complex numbers. But nonetheless, what essentially you've got from the action of a matrix on a ket vector is just a new ket vector. I need to introduce you to what is called the identity matrix. And the reason it's called an but you'll easily see how to create any dimensions, or sometimes called the unit. Take the unitary matrix and multiply it by U dagger, which you will remember is the transposed complex conjugate of U. That gives you the identity matrix. In other words, you can consider that U dagger is the inverse of U. So when you multiply U by U dagger, you essentially get the identity matrix. Then I need to explain to you what a determinant is.
So the dagger is the inverse. So that U times U inverse is identity. So that's amazing that dagger it's so easy to create the inverse.
If we want the determinant of matrix M, matrix A, B, C, D, where A, B, C, and D will all be times C. For 3 dimensions, it's a little bit more terms on the 1, 0, 0, 1. Would be 1 times 1 minus 0 times 0. The determinant of the identity matrix is B, C, D. Then the trace of a matrix couldn't be easier. It's just the sum of the elements on the main diagonal. So in this case, it will be A plus D. I wanted to know that we've almost come to the end of a thing called a Hermitian matrix, represented with the sign H, vector A, but multiplied by a number, not a vector to produce, represented with, that was when the matrix onto the physics. There's just one more thing to so a ket vector.
I didn't know what this line is here.
A, to produce the self-same vector A, but multiplied by a number, not a vector, not a matrix, just a number. It might be a complex number, but in this case, it will be a real number. So it'll have no complex, it'll have no imaginary term. And that is going to prove to be one of the most important equations in the whole of our quantum mechanics dealings. So what we're saying in maths terms is that a Hermitian matrix acting on a vector produces the same vector, but now just multiplied by an ordinary real number. And when that is the case, that vector is called an eigenvector, and that number is called an eigenvalue. What you will typically find is...
Wait, someone has joined the server? Oh, Spaghetti! What's up, Spaghetti? Hey, what's up?
I am fine, thank you. And you?
Phenomenal to the power of phenomenal. Anyway, were you on the Globe Gangster server today?
Yeah.
Did you see me there?
Maybe.
Anyway, what's on your mind?
I don't know what is that globe thing.
The Globe Gangster. I think I saw you on the Globe Gangsters server. Anyway.
Yeah, but I didn't know what is that.
It's just a server like against flat earthers. Like Globe Gangsters, they're against flat earthers. They call them
Flat earthers are retarded.
Yeah. Anyway, so I'm studying Dirac like bracket notation. Are you familiar with it?
Yeah, I've heard of it.
Oh, you heard of it? You never studied it?
No, I studied it.
You did study it?
Uh-huh.
Is it useful?
Yeah, it's pretty useful.
Oh, okay. But I think it's useful because we don't understand quantum mechanics. Like if you really understand quantum mechanics, you shouldn't need it, right?
Well, maybe it could still be useful.
Like is it like to make predictions of experiments?
Yeah, I guess so.
Like I cannot imagine any other usefulness except for it's a shorthand of the weirdness of quantum mechanics, I guess. It's a summary of the experiments, and based on the summary you can make predictions, but it's a mathematical tool, I guess. Like every other tool, it's a convenient model of reality.
Yeah, I guess so.
Yeah. Do you know you know GR, right?
Yeah, I've heard of it.
You've heard of it, but you're good at it. Anyway, so you said that the explanation okay, so what's the story with Mercury? Why does Mercury precess because of Einstein's GR? How does GR explain the precession?
Because curvature and such. I don't remember the full explanation.
What? What did you say?
I don't remember the full explanation. I'll have to look it up.
Okay. So GR says that energy creates gravity. Energy bends space-time, as they say, right?
Yeah, pretty much.
Why does that happen? Why? Because E equals mc squared, so energy is basically mass. They're interchangeable, so you could say that because
Yeah,
of
but
that.
why does mass curve space-time then?
Oh, okay. So it's for the same reason. So why is so because of the geometric tensor, whatever?
Yeah, but that's not an explanation, is it?
No. So what's the explanation?
Mhm.
Is there an explanation?
Maybe there could be.
It's like they say mass tells space how to bend, how to curve. Why?
Yeah.
Why does mass tell space how to curve? Like
No one knows.
like based on my ether theory, so ether interacts with massive bodies and annihilates and creates a vacuum. And because of dark energy, of positive pressure everywhere of ether. So then you have a pressure gradient and the ether flows from normal positive pressure into massive bodies. And as it flows, it drags everything in, and that's how you get gravity. But what does GR say? Like mass curves spacetime? Why? Why does mass curve spacetime? Like what's the mechanical explanation of GR? You see, there's no mechanical explanation of SR either. SR, there's no mechanical explanation of SR why you have time dilation. There's no mechanical explanation for time dilation. But ether gives you a mechanical explanation of time dilation and of gravity. So isn't ether a preferred theory by Occam's razor?
Well, I don't prefer it.
You don't what?
I don't prefer it.
You don't prefer it? So what causes time dilation? What's the mechanical explanation for time dilation?
There's a geometric explanation.
But what's the mechanical explanation?
I don't know what you mean.
Well, the universe is mechanical. What you need a cause and effect. What
Yeah, like a
causes
clock.
what?
Like a clock?
Well, the universe is based on cause and effect. So what causes time dilation? What causes what?
Frames cause it.
Frames?
Yeah, frames.
What do you mean frames? Reference frames?
Yeah, they cause it.
Reference frames cause time dilation?
What's up?
What's up? I saw you on the YouTube. Your Palveron clips.
My main channel is Pulveron. But it mistakenly put into Pulveron clips. It was a the mistaken account. Mistake.
So what do you mean by timeout?
I was timed out in Globe Gangsters.
Oh, why? Why were you timed out?
I've put I've put the YouTube. I've distracted with a YouTube activity.
You
Um,
okay?
I've
Anyway,
distracted everyone here.
okay. Anyway, spaghetti. So, do you understand my question? Like, what causes time dilation and what causes gravity?
Uh, I don't know.
Uh-huh. Trevor, why do you have your video on?
I need to see. I don't know. I must get my video on in here.
You don't know how to shut it off?
I don't want to turn it off because I don't want to turn it off.
Why not?
They're gonna see me famous in the live stream.
They're gonna see you what?
You're gonna see me at the live stream, at your live stream.
Oh, you want everyone to see you?
Yep, because some subscribers are. I have 12 subscribers, and anyways, it's getting time now. It's getting time for lunch. So
Okay,
goodbye.
bye.
Goodbye.
See you later. Oh my god. Oh my god. Oh my god. Anyway, spaghetti. So I need that's the advantage of the ether theory. The ether theory gives you a mechanical cause and effect. It causes time dilation mechanically. And it causes gravity mechanically. And it causes the quantum field and the elementary particles mechanically. It's a mechanical theory. It's so beautiful. It's so simple.
Okay.
Do you love it?
No.
Oh, okay. But you don't have an alternative theory. It's the only theory that you have in order to explain cause and effect, the time dilation.
I didn't hear you anyway. I'm going to go eat lunch.
Okay, bye.
Bye.
Bye. All right, I'm going. My brain fell asleep during this conversation. I'm sorry. Gotta go. All right, bye bye.